Picture the ocean. Not the ocean you know, the vast and silent blue. Imagine a different ocean. Imagine walking onto a beach in the middle of the night and hearing something that should not exist. A sound like 10,000 shaken bottles cracking open all at once. A hiss. A roar. A fizz that rises from every wave, from every shoreline, from every current on Earth. Imagine the water glowing faintly brown under the moonlight, thick and sweet-smelling, churning with bubbles that never stop rising. Every ocean, every sea, every bay and inlet and fjord, all of it. In a single instant, every body of salt water on the planet has become carbonated, sugary soda. Not metaphorically, not slowly, instantly. 330 million square kilometers of ocean gone, replaced. In the time it takes your heart to beat once, the most fundamental feature of the Earth, the cradle of all life, the engine of all weather, the largest habitat in the solar system, has been swapped for something that belongs on a supermarket shelf. This is not a thought experiment about convenience. This is the opening second of the largest ecological catastrophe in the history of the planet. Larger than any asteroid, larger than any volcanic winter, larger than anything life has ever endured. And you are alive to see it happen. In the next 30 minutes, we will walk through every stage of what comes next. The death of the sea, the unraveling of the sky, the collapse of the food you eat, the desperation of every government, every scientist, every family on Earth, trying to find one clean glass of water. And by the end, you will understand just how much of your existence depended on something you never once thought about. The plain, bitter, beautiful saltiness of the sea. In the first minute, the physics goes mad. The average ocean temperature at the surface is about 17 degrees Celsius. Soda, as we know it from a can, is pressurized. The dissolved carbon dioxide stays locked inside because the pressure inside the container is far higher than the atmosphere. But the ocean is open. There is no lid. So when 330 million cubic kilometers of water instantly becomes carbonated, the gas fights to escape all at once. The surface of every ocean on Earth erupts. Geysers of foam shoot meters into the air along coastlines. Ships at sea report the water beneath them boiling, not with heat, but with gas. The foam is so thick and so persistent that in some regions it piles into drifts meters deep along the shore, like brown snow. Navigation becomes impossible. Radar and sonar fail because the water is now saturated with bubbles that scatter every signal. Within the first hour, the amount of carbon dioxide released into the atmosphere is staggering. We are not talking about a few million tons. We are talking about the equivalent of centuries of human industrial emissions, dumped into the sky in 60 minutes. The atmosphere already held about 420 parts per million of carbon dioxide. Within hours, monitoring stations around the world watch that number climb past 800, past 1200, past 2000. The greenhouse effect does not wait politely. The planet begins to warm, but that is the least of the immediate problems, because while the gas escapes upward, something else spreads outward. The sugar. Every liter of ocean water now contains roughly 100 grams of dissolved sugar. That sugar does not stay in the sea. It coats everything. It washes onto beaches, into estuaries, into the mouths of every river that meets the coast. Within hours, coastal cities report a sticky brown film on every surface exposed to sea spray. Cars stall as sugar coats their engines. Electrical transformers short out as the mist settles into every gap. And in the water itself, something far worse is already beginning. The sugar is food, and the sea is full of organisms that eat. The first thing to die is the plankton. Phytoplankton are the foundation of the entire marine food web. They are also some of the most chemically sensitive organisms on Earth. They evolved over hundreds of millions of years to thrive in water with a pH of about 8.1. Slightly basic, slightly salty. full of trace minerals in ratios that have barely changed since the age of the dinosaurs. Now, in an instant, that water has a pH of 3. It is acidic, it is carbonated, it is saturated with sucrose and high fructose compounds that no ocean organism has ever encountered. The cell membranes of phytoplankton rupture. They do not adapt. They do not migrate. They simply dissolve. Within 6 hours, satellite images show the oceans changing color. The green and turquoise patches that once marked the great phytoplankton blooms, the pastures of the sea, are gone. The water turns a uniform dark brown. Then the zooplankton die. They had nothing to eat, and the water itself was poisoning them. Then the small fish. Then the large fish. Fish gills are delicate structures designed to extract oxygen from water while keeping salt out. They are not designed to process carbonic acid and sugar. The gills inflame. The blood chemistry of every marine vertebrate collapses as pH drops below what their bodies can tolerate. Sharks, tuna, salmon, cod. Every species that breathes through gills suffocates from the inside. Within 24 hours, every fish in every ocean is dead. That is not an exaggeration. Every fish. Coral reefs, already fragile, dissolve. The calcium carbonate skeletons that took thousands of years to build begin to erode in the acidic water within days. The entire Great Barrier Reef, the entire Caribbean reef system, the reefs of Indonesia and the Red Sea, all of it turns to sludge. Marine mammals fare no better. Whales and dolphins breathe air, true, but their skin burns in the acidic water. Their food is gone. The krill they depend on died with the plankton. Within a week, whales beached themselves in unprecedented numbers, their bodies blistered, their stomachs empty. Sea turtles, sea snakes, sea lions, seals, every creature that depends on the ocean dies. The largest mass extinction in the history of complex life unfolds in a single week. Not over 65 million years like the dinosaurs. Not over hundreds of thousands of years like the Permian extinction. In 7 days. Now the dead ocean begins to rot. This is where the catastrophe moves from catastrophic to apocalyptic. 330 million cubic kilometers of seawater, once home to roughly 1 billion trillion living organisms, is now a graveyard. And in warm water, full of sugar, full of dead organic matter, bacteria bloom. Not the bacteria that normally decompose marine life. Those mostly died too, but the kind of bacteria that thrive in warm, acidic, sugar-rich environments. The kind that normally live in rotting fruit, in fermentation vats, in the slimy residue of a forgotten soda can. Within 2 weeks, vast stretches of the ocean surface are covered in a thick, fermenting scum. The smell reaches coastal cities. It is not a smell anyone has ever encountered at this scale. It is the smell of a brewery the size of a planet. Fermentation produces alcohol. The bacteria and yeasts that have colonized the Dead Sea begin producing ethanol in quantities that boggle the mind. The ocean, in places, becomes a weak alcoholic solution. This is not a joke. This is a catastrophic alteration of global water chemistry. The alcohol evaporates faster than water, adding volatile organic compounds to the atmosphere. The air above the oceans becomes a haze of ethanol vapor, sugar aerosols, and carbon dioxide. Rain begins to fall that is not rain. It is a sticky, faintly alcoholic mist that coats every surface it touches. Inland lakes and rivers connected to the sea through estuaries or through the water table begin to change. The sugar and acid creep upstream. The Mississippi, the Amazon, the Nile. Every great river that empties into the sea sees its lower reaches turn brown and sweet. Freshwater fish die by the billions. Amphibians, whose porous skin makes them extraordinarily sensitive to water chemistry, die almost instantly when the soda reaches them. Frogs, toads, salamanders, the entire class of animals that scientists consider the most endangered on Earth, vanish from every wetland on the planet within a month. The ocean is no longer an ocean. It is a dead, fermenting, acidic lake that covers 70% of the Earth's surface. and it has only just begun to reach into the sky. To understand what happens next, you have to understand how the ocean controls the weather. The ocean is the planet's thermostat. Sunlight hits the sea, the water evaporates. That vapor rises, cools, condenses into clouds, and falls as rain or snow. That cycle carries heat from the equator to the poles, drives the jet stream, shapes the monsoons, and determines where every desert, every rainforest, every fertile plain on Earth sits. Every drop of rain that falls on land, every snowflake that forms over a mountain, every cloud that drifts across a continent began as water that evaporated from the sea. Now the sea is soda, and soda does not evaporate like water. The sugar in the water changes its vapor pressure. It evaporates more slowly. But what does evaporate is not pure water vapor. It carries sugar molecules, organic acids, and volatile compounds with it. The clouds that form above the ocean are no longer white wisps of condensed water. They are thick, brownish, sticky clouds that rain something closer to diluted syrup than fresh water. Within the first month, the global rainfall pattern breaks down. The intertropical convergence zone, the band of storms that circles the equator and drives the climate of the entire tropics, sputers and stalls. The trade winds weaken because the temperature differential between the equator and the poles, the engine that drives them, has been disrupted by the changed evaporation pattern. The monsoon season fails. In India, in Southeast Asia, in West Africa, the rains that 1 billion people depend on to grow their food simply do not come. Or they come as a brown, sticky rain that kills the crops it touches. Sugar deposits coat the leaves of rice, wheat, and maize. The plants suffocate. Photosynthesis slows to a crawl as a film of organic sugar blocks the stomata. Within weeks, fields across the tropics turn yellow, then brown, then dead. By month 3, the climate system is in free fall. The excess carbon dioxide in the atmosphere has raised global temperatures by several degrees. But that warming is now secondary to a much more immediate crisis. The ocean currents have stopped. The great thermohaline circulation, the vast conveyor belt that carries warm water from the equator to the North Atlantic and cold water back again, depends on a precise relationship between temperature and salinity. Cold, salty water sinks. That sinking drives the entire global current system. But the ocean is no longer salty. It is sugary. The density of the water has changed. The deep water formation that occurs in the North Atlantic and around Antarctica, the mechanism that powers the Gulf Stream and every other major current on Earth, ceases. The Gulf Stream stops. Europe, which owes its mild climate to the warm water dragged across the Atlantic from the Caribbean, begins to cool dramatically. Within a year, average temperatures in Britain, France, Germany, and Scandinavia drop by 10 degrees. Snow falls in June. The growing season collapses. Meanwhile, in the tropics, the opposite happens. Without the ocean currents redistributing heat, the equatorial regions bake. Temperatures in the Amazon, in Central Africa, in Indonesia, regularly exceed 50 degrees Celsius. The Amazon rainforest, already stressed by the failing rains, catches fire. Not in patches as it does now. The entire basin burns. The smoke from the Amazon joins the smoke from dying forests across the tropics and creates a global haze that blocks sunlight. The planet is simultaneously warming from greenhouse gases and cooling from smoke haze, and no climate model on Earth can predict what happens when those two forces collide, because no climate model was ever built to simulate a soda ocean. What the models do show is that the pattern stabilizes into something brutal. A frozen north, a burning equator, a temperate band that shrinks to a narrow ribbon around the mid-latitudes, the only region where both rainfall and temperature remain within the narrow window that human agriculture can tolerate. And even there, the rain is not clean. Let us talk about food. Before the event, the ocean provided about 17% of the protein consumed by humanity. That is gone. Every fishery on Earth is dead. Every aquaculture facility is dead. Every coastal community that depended on the sea for sustenance is staring at an empty, toxic shore. But the collapse of the food chain does not stop at seafood. The marine food web that died in the first week was connected to the land in ways most people never consider. Seabirds. Seabirds that numbered in the billions, that nested on every coastline and island on Earth, that fed on fish and plankton and carried nutrients from the sea to the land, are gone. Every albatross, every pelican, every puffin, every penguin, every tern and gull, dead within 2 weeks of starvation and poisoning. The nesting sites they once occupied, the islands and cliffs where their guano nourished entire island ecosystems, go silent. But the agricultural collapse is what truly threatens human survival. The failing monsoons have killed the rice harvest across Asia. The sugar rain has poisoned the wheat fields of Europe and North America. The sudden cooling in the north has shortened the growing season in Canada and Russia, two of the world's largest grain exporters. Global grain production, which before the event fed over 7 billion people, drops by more than half within the first year. Food prices skyrocket, not to double, not to triple, to 10 times their previous value, then 20 times. Then they simply stop being available. National governments ban food exports overnight. The global trade in grain, rice, soy, and cooking oil ceases. Countries that imported the majority of their food, Japan, Egypt, Saudi Arabia, South Korea, dozens of others, face famine within months. And the livestock, the animals that humans raise for meat and dairy, depend on clean water and clean feed. The sugar-contaminated rain fouls every pasture, every pond, every trough. Cattle develop metabolic shock from drinking sugary water. Their rumens, adapted to ferment grass, go into dysfunction as the sugar disrupts the bacterial balance in their digestive systems. Dairy cows stop producing milk. Beef cattle die in their pens. Poultry farms lose entire flocks to kidney failure as their bodies try to process the sugar and acid in every drink they take. Within a year, the global livestock population has been reduced by more than 70%. Meat and dairy, already luxuries in much of the world, become rumors. The human food supply, once a vast and complex global system, has been reduced to whatever can be grown in the narrow temperate band where the rain is still mostly water. The soil is not yet saturated with sugar, and the temperature still permits crops to survive. And now we come to the crisis that strikes closest to every human body: drinking water. Before the event, about 2 billion people already lacked reliable access to clean drinking water. After the event, that number becomes everyone. The surface water of the earth, every river, every lake, every reservoir that is connected even tangentially to the ocean or to the coastal water table, is contaminated. The sugar is everywhere. It is in the rain. It is in the rivers. It is in the shallow aquifers that feed wells across every inhabited continent. You cannot drink it, not because it tastes bad, though it does, because it will kill you. A human body is not designed to ingest sugar-saturated water. The kidneys, which filter about 200 liters of blood a day, are built to handle a very narrow range of blood sugar. When you drink water that contains 100 grams of sugar per liter, you are effectively drinking a concentrated syrup with every sip. The blood sugar of anyone drinking this water spikes to levels that would put a diabetic into a coma. Insulin production goes into overdrive and then fails. People who drink the contaminated water develop acute hyperglycemia, vomiting, diarrhea, and kidney stress. Children and the elderly die first. Dehydration, paradoxically, accelerates because the sugar in the water draws fluid out of the body's tissues through osmosis. The more soda water you drink, the more dehydrated you become. And the acid. The carbonic acid in the water erodes tooth enamel within days. It inflames the stomach lining. Ulcers become universal. The intestinal microbiome, that delicate balance of bacteria that helps humans digest food and regulate immunity, is destroyed by the acid and sugar flooding the gut. People who survive the initial poisoning develop chronic gastrointestinal disease, yeast infections, systemic fungal overgrowth. The human body, in short, is not built to run on soda. Every city in the world faces the same crisis. The water supply is contaminated. The treatment plants were designed to filter sediments, bacteria, and chemical pollutants. They were not designed to remove dissolved sugar and acid from water on a planetary scale. The filters clog. The chemical treatments fail. The pipes, coated in sugar residue, become breeding grounds for bacteria and mold. Within weeks, every municipal water system on Earth is either shut down or dispensing water that is slowly killing the people who drink it. But humans are not passive. They never have been. Within the first weeks of the crisis, the response begins. And it is chaotic, desperate, and brilliant in the way that only existential panic can produce. The first priority is clean water. And there is exactly one source of water on Earth that has not been touched by the soda. Deep aquifers, fossil water, sealed underground for tens of thousands of years, trapped beneath impermeable layers of rock that the contamination cannot reach. Every nation with access to deep aquifers begins drilling. The Ogallala Aquifer beneath the American Great Plains, the Nubian Aquifer beneath the Sahara, the Great Artesian Basin beneath Australia. Every deep groundwater reserve on Earth becomes the most valuable resource on the planet. Wells are drilled deeper than ever before. The technology of hydraulic fracturing, developed for oil and gas extraction, is repurposed to reach water. Governments nationalize their groundwater. Militaries are deployed to guard wells. In regions without access to deep aquifers, the solution is desalination. But the ocean is no longer salt water. It is sugary acidic soda. Standard desalination, which uses reverse osmosis to separate salt from water, can theoretically remove sugar as well. Sugar molecules are larger than salt ions, which means they are easier to filter out, in principle. In practice, the sheer volume of organic matter in the water fouls every membrane. The sugar feeds bacteria that colonize the filters within hours. The acid degrades the membranes. Every desalination plant on Earth has to be rebuilt from scratch. Engineers work around the clock. New filtration systems are designed, combining reverse osmosis with activated carbon, biological treatment, and chemical neutralization. The first plants that can produce clean water from the soda ocean come online within 6 months. They are expensive, slow, and produce a fraction of what the old plants did, but they work. Inland, communities turn to every possible source. Rainwater harvesting becomes universal, but the rain itself is contaminated. So people build distillation units, simple boiling stills, solar concentrators, any device that can evaporate water and leave the sugar behind. The technology is ancient, but it scales. Every household that can build a still has clean water. Every household that cannot does not. The divide between those who can engineer their own survival and those who cannot becomes the defining social fracture of the new world. The global economy does not collapse. It transforms. The old economy, built on trade, services, finance, and consumer goods, disintegrates within the first year. Stock markets close. Currencies lose meaning. The new economy is built on 3 things: water, food, energy, and not necessarily in that order. Water becomes the universal currency. A liter of verified clean water is worth more than gold, more than oil, more than any currency any government can print. Barter economies emerge in every community. A farmer with a working still trades water for seeds. An engineer who can repair a filtration membrane trades labor for food. The old professions, the bankers and marketers and consultants, vanish. The new professions are the old ones. Well driller, distiller, filter maker, seed saver, soil chemist, solar engineer,
doctor.
The skills that kept humans alive for 10,000 years become the only skills that matter. Governments that still function focus everything on three goals: securing water, producing food, maintaining energy. The energy problem is critical. Every desalination plant, every distillation unit, every deep well pump requires power. And the fossil fuel infrastructure is failing. Offshore oil platforms are useless. The sea is toxic. Coastal refineries are corroding in the acidic spray. Coal and nuclear plants inland become the backbone of survival. Every nation with coal reserves burns them without regard for emissions, because the alternative is death by thirst. The irony is brutal. The carbon dioxide already released from the soda ocean has warmed the planet, and now the survival response adds more. But no one has the luxury of worrying about climate change 50 years from now, when the crisis is today. Nuclear power becomes the most prized technology on Earth. Reactors that were being phased out are restarted. New reactors are built with wartime urgency. The splitting of atoms to boil water, to drive turbines, to power the machines that clean water becomes the single most important industrial process on the planet. And food. The narrow temperate band where crops can still grow becomes the most contested real estate on Earth. Nations that were once superpowers, whose territories span multiple climate zones, focus everything on preserving the agricultural heartland that remains. The American Midwest, the Ukrainian steppe, the Argentine pampas, the Chinese interior. These regions, already breadbaskets, become the sole sources of survival for their nations. Armies are redeployed from every foreign base, every overseas commitment to guard the fields. Fertilizer becomes a controlled substance. Seeds are nationalized. Every calorie is accounted for. 3 years in. The world population, which stood at just over 8 billion before the event, has fallen. The exact number is impossible to determine because communication systems have fragmented and many governments have collapsed. But the best estimates from surviving research institutions suggest the global population has dropped to between 3 and 4 billion. That is 2/3 of the previous number. The dead are counted in the billions. Famine, dehydration, disease, violence over resources. The sugar water poisoned the bodies of those who had no choice but to drink it. The failing crops starved those who had no access to the remaining fertile zones. The collapsing medical systems could not treat the epidemics of kidney disease, gastrointestinal infection, and fungal overgrowth that swept through every contaminated population. Wars were fought over aquifers, over fertile valleys, over desalination plants. Small wars mostly, between desperate communities, but in some regions, wars between nations. India and Pakistan fought over the Indo-Gangetic aquifer. Several Central African nations collapsed into a continuous conflict over the Nubian water reserves. Brazil and Argentina clashed over the Parana Basin. But out of the wreckage, something stabilizes. Humans adapt. It is what the species does. The deep aquifers are being managed now, not drained in panic, but pumped sustainably. The desalination technology has improved. The first generation of filters designed specifically for sugar water is now operating in hundreds of plants worldwide. The output is still a trickle compared to the old world, but it is reliable. Agriculture has been reinvented. The narrow temperate band is now home to vast, intensive farming operations that use every available technology. Hydroponics, aeroponics, vertical farming. All the techniques that were once niche and experimental are now the primary source of food. They do not depend on rain, on soil, on the natural cycles that have been destroyed. They depend on energy, on clean water, on controlled environments. And humanity has those. Barely. The old coastal cities are largely abandoned. The sugar spray corroded the infrastructure. The contamination seeped into every water source, and the economic collapse made urban life impossible. The new population centers are inland, near aquifers, near geothermal energy, near the surviving nuclear plants. They are smaller, denser, more engineered, They are cities built around the water still, around the filter plant, around the grow tower. The ocean is still soda. It will be soda for a long time. The sugar will eventually be consumed by bacteria and broken down. The carbon dioxide will eventually be absorbed by the remaining geological processes, by weathering of rocks, by the slow chemical cycles that have regulated Earth's atmosphere for billions of years. But that will take thousands of years. In the meantime, the ocean is dead, brown, fermenting, slowly being digested by the microbes that have colonized it. The sea level has actually risen slightly because the sugar has increased the density and volume of the water, and because the warming has expanded it. The coastlines have shifted. The maps have been redrawn. Stop for a moment and consider what has been lost. Not the human cost, though that is incalculable. Consider what has been lost from the Earth itself. The ocean was the largest habitat on the planet. It contained the greatest diversity of life, the deepest mysteries, the most ancient lineages. Every whale song, every coral reef, every bioluminescent creature in the deep dark, every fish that ever flickered through a current, every turtle that navigated by magnetic field across an entire ocean basin. All of it, gone. The deep sea, the abyssal plains, and the hydrothermal vents, the places where life may have first originated on this planet, are dead. The organisms that lived at the vents, the tube worms and the blind shrimp, and the archaea that drew energy from the Earth's internal heat rather than the sun, they survived every previous extinction. They survived the asteroid that killed the dinosaurs. They survived the Permian extinction that killed 90% of all species. They did not survive this. The ocean was also the planet's memory. The layers of sediment on the seafloor contained the climate history of the Earth, the record of every ice age, every warm period, every asteroid impact, every volcanic eruption, going back hundreds of millions of years. That record is being dissolved by the acid. The history of the Earth, written in mud on the ocean floor, is being erased. Future geologists, if there are future geologists, will find a strange layer in the rocks, a layer of brown, sugar-rich sediment, full of the dissolved remnants of every marine organism that ever lived, marked by a sharp chemical boundary where the pH of the entire ocean dropped from 8 to 3 in a single instant. They will call it the soda boundary. And they will wonder what kind of catastrophe could do such a thing. But perhaps the greatest loss is one that humans never fully appreciated, even when it was there. The beauty of the sea, the sound of waves on a shore, clean and salt and wild. The color of the open ocean, that impossible deep blue that exists nowhere else in the solar system. The feeling of standing at the edge of a living world, vast and ancient and indifferent to your existence. That is gone. The shore still has waves, but they are brown and sticky, and they smell of fermentation. The water is not blue. It is the color of old cola and the living world that it contained. The world that was older than humanity by hundreds of millions of years is a memory that no one who survived will ever be able to fully convey to those who come after. 10 years after the event, the population has stabilized at around 3 billion. The birth rate, which collapsed in the first years of the crisis as malnutrition and stress made reproduction difficult, has begun to recover. The generation born after the event will never know the old world. They will grow up in the inland cities, drinking filtered water, eating food grown in towers under artificial light. They will learn about the ocean in history books, the way we learn about the Ice Age, as something vast and distant and gone before anyone alive can remember. The climate has settled into its new pattern. The north is cold, the equator is hot, and the temperate band is where everyone lives. The soda ocean is slowly changing. The sugar is being consumed. The bacteria that colonized the Dead Sea have metabolized most of the sucrose, and the water is now a weak, acidic, alcoholic solution that is slowly losing its sugar content. It will take centuries, perhaps millennia, before the ocean returns to anything resembling its former chemistry. and it will never return to its former life. The marine ecosystem, built over hundreds of millions of years of evolution, is gone. Whatever life eventually recolonizes the sea will be something new. Bacteria, microbes, perhaps over millions of years, something more complex. But the whales, the fish, the coral, the plankton, the entire intricate web of marine life that once covered 70% of the planet is as extinct as the trilobites. Humanity survives. That is the lesson. Not comfortably, not easily, not without a cost measured in billions of lives and in the permanent loss of the most beautiful feature of the Earth. But the species survives because humans are the organism that can build a still, that can drill a well, that can split an atom to power a filter. The species that could not survive in the ocean, that never evolved for the sea, that crawled out of the water hundreds of millions of years ago and never went back, is the species that endures when the water itself becomes hostile. There is a bitter irony in that. The creatures that lived in the sea for 1 billion years are gone. The creature that left the sea, that learned to walk on land and build fire and forge metal and split the atom, remains. And perhaps in the fullness of geological time, that creature will do what it has always done. It will adapt. It will rebuild. It will fill the empty ocean with something new, something of its own making. Or perhaps it will simply learn to live beside a dead sea and remember what it once was. The ocean was the cradle of life, and in a single instant, the cradle became a grave. But life, as it has always done, found a way to crawl out of the grave and stand on the shore. Even if the shore is sticky and brown and smells of sugar, even if the water will never be blue again, life finds a way. That is the story of this planet. That is the story of us.